This is a video from the Key Stage 3 topic, Light and Sound, looking at the structure of sound waves and the loudness and the pitch of sound waves. So here we've got the sound waves. Now we can use a signal generator and an oscilloscope to analyse sound waves, which we'll have a look at in a second. When we look at this picture of a sound wave, we can see that from that centre point to the peak is the amplitude, or indeed from the centre point to the trough is the amplitude of the sound, and the amplitude is linked to the loudness of the sound. So big amplitude means loud sound. The wavelength is from any point on the wave to the same point on the wave. Here you can see it's from one peak to another peak, could be from a trough to a trough, could be from any point on that wave to when that point occurs again is the wavelength. And then the frequency of the sound is how many waves pass a point in a second, and the frequency is linked to the pitch of the sound. Okay, as you can see, I've got my signal generator creating the sound. I've got my oscilloscope representing the sound as a wave, and I've got a loudspeaker. So if we go in closer to the oscilloscope, you can see the amplitude of this wave is very short, so it's quite a quiet sound. If I increase the volume, you can see the amplitude increases. We can hear the volume, the loudness of the sound increasing. It's becoming louder and louder, and the amplitude is representing this. The frequency of the waves hasn't changed because the pitch has stayed the same, okay? But the amplitude increases as the loudness increases. So as we just saw there on the oscilloscope, the louder the sound got, the bigger the amplitude became, okay? So we saw the waves had a really small amplitude at the beginning because the sound was very soft, and then as we increased the volume on the signal generator, the amplitude got much bigger and we heard the sound get much louder, okay? We didn't change the pitch at all in that demonstration, and we could see that because, as you can see on these diagrams here, there's the same number of peaks in both diagrams and the same number of troughs in both diagrams for that same given space. So we know that we haven't changed the frequency of the sound, therefore the pitch hasn't changed. All we did was we increased that volume, which increased the amplitude. Okay, now to take a look at the pitch of the sound. So as I increase the frequency, you can hear the pitch of the sound is increasing the frequency, increasing the pitch of the sound. As we just saw on that video, the pitch of the sound increased as we increased the frequency of the sound. So as I turned on the signal generator, the frequency of the sound increased. We saw that represented on the oscilloscope because we saw more waves. The frequency was, they were much closer together, and we could hear the difference, and the pitch was much higher, okay? They both had the same amplitude, so we hadn't changed the volume of the sound. All we did was change the frequency, which made the pitch go up and the frequency increased. Hope you found that useful. Thank you.